Hello everyone. Today we're going to go over formation of ionic compound. So formation of a chemical bond um, between positive and negative ions. And terms to review are octet rule, which is the gain and loss of electrons to have 8 on the outer shell. So we either um, gain or lose or share electrons to get to 8. So in this section, it's gain or lose. So a chemical bond.
Chemical bond, the force that holds two atoms together, may form by the attraction of a positive ion for a negative ion or by sharing electrons.
Okay, so these are forces that hold atoms together, and it's usually between positive and negative. Positive of one nucleus, of a nucleus of one atom, and a negative of negative electrons of another atom. So positive and negative. We talked before about metals, usually lose.
Cation, an ion that has a positive charge.
Okay, and anion.
Anion, an ion that has a negative charge.
Okay, so an ionic bond is it's a complete transfer of electrons between a metal and a nonmetal, positive and negative charge. so, so it's a complete transfer of electrons between atoms. If it's a sodium, it has one valence electron. Chlorine has 7 valence electrons. If sodium completely transfers one electron, then it gets to the next shell which has 8, and then the outer shell for chlorine would have 8. When sodium loses, it becomes positive. When chlorine gains, it becomes negative.
Ionic bond, the electrostatic force that holds oppositely charged particles together in an ionic compound.
Okay, so oppositely charged, electrostatic force between oppositely charged. Now the compound.
Ionic compounds, compounds that contain ionic bonds.
And it's usually between a metal and nonmetal. So later on we'll go over covalent, which is nonmetal and nonmetal. That's something you need to remember. So ionic is complete transfer, and it's between metal and nonmetal. And in the structure is called
Crystal lattice, a three-dimensional geometric arrangement of particles in which each positive ion is surrounded by negative ions and each negative ion is surrounded by positive ions. Varies in shape due to sizes and relative numbers of the ions bonded.
Okay, alternating positive and negative. And due to that structure, the properties of ionic bonds is very strong, and it has crystalline solids. It's usually high melting points, high boiling points. Because of the strong attraction of ion between, um, it has high melting and high boiling. It also conducts because of all the ions held together, all the charges, and it's soluble in water. So usually I do a demo in class where we have water, sugar, and sodium table salt or sodium chloride. Um, Usually water does not conduct because it's neutral, and sugar also does not conduct because it's non-electrolyte. But salt is an electrolyte and it conducts electricity. It has electrons floating.
Electrolyte, an ionic compound whose aqueous solution conducts an electric current.
We've done this before for metals where uh, when electrons are just floating, it completes the circuits. Now, this explains how the crystals shatter or break. When you hammer it, it realigns, and instead of positive negative, you can get the similar charges close to each other and they repel, and that's why it shattered the crystals. Now, you're going to need this periodic table because we're going to go over how the ionic compounds form. So you will need this one. I took a picture of it, but get one just in case to complete your homework and your assignments. So we're going to go over the formation of these compounds. And before we start, let me see. Go ahead and print out those blank um, slides. So click on the first one and then shift and highlight to the last one. Um, Print. But when you print, select your printer and then print selected slides and make sure it's not this one. It's this arrangement right here. Now you can do 6, but that's too small. So this one will be 2 pages. All right. And then we're ready to do our assignments or practice. Okay, just fill it in as we go. The first element is sodium and nitrogen. Now we look at sodium right here. It says group number or valence electrons. It says in 1A, so we have 1 electron. Oh, the sample is Na and N. The group number is 1 electron, 1 valence electrons. For nitrogen, it's 5A, so it has 5 valence electrons. Now, to satisfy the octet rule, we ask ourselves, is it easier to lose 1 or gain all 7? And the answer is, it's easier to lose 1, the least number. Now, for nitrogen, is it easier to gain 3 to get to 8 or lose all 5? And we always go with the least number, so gain 3. So when it loses 1, it becomes positive 1. Gain 3, it becomes negative 3. And we use a method called crisscross, where you bring that number to the bottom without the charges. So it takes 3 sodiums for every 1 nitrogen. So think of it as you need Na plus, Na plus, Na plus to make positive 3 to neutralize negative 3. Okay, let's do one more. Lithium and oxygen, Li and O. Li has 1 valence electron. Oxygen has 6. It's easier to lose the 1 to satisfy the octet rule, because once you lose the 1, it goes to the next shell, which has already satisfied the octet rule. For 6, it's easier to gain 2. So lithium becomes positive 1, oxygen becomes negative 2, and then we do the crisscross. So it takes 2 lithium for every 1 oxygen. That's the formula that you end up with. Of course, next section we're going to learn how to name ionic compounds. Now the next one is strontium and fluorine. Strontium is Sr, fluorine is F. Fluorine is right here, but strontium is right below 2A, so it has 2 electrons. Fluorine has 7. It's easier to lose the 2 than gain 6. For fluorine, it's easier to gain 1 than lose all 7. So when you lose 2, it becomes positive 2. And fluorine, it becomes negative 1. And then we do the crisscross. So it takes 2 fluorine for every strontium. Right? I think we have one more. Aluminum and sulfur, Al and S. Al is 3, so it has 3 valence electrons. Sulfur has 6. It's easier to lose 3. And another thing to remember is the first one always loses, the second one always gains. Sulfur, it's easier to gain 2 to get to 8. So aluminum becomes positive 3, sulfur becomes negative 2. And then we do the crisscross. So that aluminum gets 2, sulfur gets the 3. So it takes 2 aluminum and 3 sulfur to neutralize this compound. This, I think, one more. Cesium and phosphorus. Now cesium is CS, phosphorus is P, and then cesium is right here below 1A, so it has 1 electron. Phosphorus is 5 valence electrons. It's easier to lose 1 than gain all 7. For phosphorus, it's easier to gain 3 than lose all 5. And then when you lose 1, it becomes positive 1. When you gain 3, it becomes negative 3. And we do the crisscross. So it takes 3 cesium for every 1 phosphorus to neutralize. And that's it for sections 1A. I'm sorry, 8.1 and 8.2. Next time we'll learn how to name ionic compounds. Hope that helps. Right, take care.